Okay, so welcome everybody to the Summer Faculty Research Showcase. My name is Caitlin Kidder. I worked with our lovely students and faculty this summer to coordinate all of the research that's been happening that we're proud to present to you today here. I formerly worked as an academic advisor for Khoury Graduate Students on the Seattle campus, and I just started a new role as Associate Director of Network Operations, which means I get to do fun things with students that go across the entire Northeastern network. I'm really proud to say that we have faculty, staff, and faculty and students rather, from all 6 of Northeastern's campuses where we have Khoury College programs represented in these projects. We have 13 presentations from 13 different research groups. They should last about 5 minutes long, so you'll get a nice bite-sized conference-style presentation that will hopefully sum up everything they have done this summer. So just to give you a little overview of where we will go today, we'll have some opening remarks from Greg Waters. We're really excited to have Greg here, and I'll introduce him a bit more on the next slide. We will then have our student presentations, and we will have closing remarks by Dr. Raman Chandrasekhar, who is a faculty member on the Seattle campus, who is one of the research group sponsors this summer. And then we will do breakout rooms. So there will be breakout room per student research project. So if you have further questions or comments, or you want to chat with those researchers about what their process was like, you're welcome to join them in their breakout room. So I would like to next introduce Greg Waters for a few words. Greg is a huge supporter of these types of research opportunities for master's students at Khoury College. Greg is an MSCS alum from Khoury. He is also the founder of Matrix Space, which is an AI systems company. He is the former president and CEO of Integrated Device Technology and serves on the boards of Sierra Wireless, on Semiconductor, and Mythic. So Greg, I would like to pass it over to you. Thank you so much for being here today.
Well, thank you, Caitlin. And it sounds like such a formal introduction. And so I'm kind of looking at that and wondering who that guy is, but yeah, I did that. But listen, I'll keep it brief. I'm really happy to be invited to be part of this today, and just a few personal comments. I did actually pull off an MSCS, as Caitlin mentioned, from Northeastern back in the day. It was early 1990s. And it was the early days of artificial intelligence, and Northeastern had brought in this prolific staff of professors, and we're really, one of the universities leading the charge in that decade on AI. So it was a cool experience. I didn't have a computer science undergrad, so I will say the first year almost killed me in terms of learning all the things I didn't know. And in terms of research, I've always been fascinated to work around really intelligent people, which you find an abundance of in tech, and fascinated by people that kind of lived on the edge of, engineering is really difficult and fun. I'm a product guy by nature, so I love to put stuff together or see things come together that create cool products. But in engineering, you are usually working on things that can be made to work. It's time and energy, and it's difficult and often frustrating, but your confidence as an engineer or a computer scientist, et cetera, tends to be pretty high, that with enough time and energy and money, you can make this thing work on that. Research is different. Research is kind of out there on the edge a little bit. You're not sure that you can make things work. And even if it does, is this the best approach, or are there others? So I think research attracts a certain, or applied research in particular, attracts a certain type of person that I enjoy hanging out with. I think it's daunting. If I went back to, even if I had the intellectual capacity, which I probably don't, to do good research, I would have been intimidated by research in the era I was doing my graduate studies. So I think to have a forum like this, where people can bounce around ideas and experience in research, is just fantastic. I credit Caitlin to Northeastern for pulling this off. And listen, with that, I will turn it back over to Caitlin and the rest, but look forward to hearing what all of you have been up to. And if you made it here, you've already done something pretty good. So I look forward to listening.
Thank you so much, Greg. We're, again, very appreciative to have you here and, share your wealth of life experience and see where research can take you in academic contexts, in industry contexts. We just want to be really supportive of our students who do have that drive to pursue a research-oriented career going forward. So I really appreciate you being here. Greg's role in the rest of this showcase, just so everybody is aware, is Greg will give some short feedback to each of the research groups after their presentation. So again, these are 5-minute presentations with just 1 minute of kind of wrap up afterwards. To help you kind of keep track of where we're at in the presentations and see kind of where we're going and help you remember which groups you would like to follow up with. I do have a kind of conference program of sorts that contains all of the abstracts written by the student groups at the conclusion of their projects as best as they can. So I am about to share that in the chat. It'll be a PDF file. You're welcome to open that and follow along and make notes on it, or just it'll help you find the breakout rooms later when we are doing those. So please find that file in the chat. And again, if you have any questions as we launch into the student presentations themselves, any concerns or issues with the Zoom, please feel free to DM me here or just put it in the chat. I would hold on to your questions that you might have for the students until you have an opportunity to speak with them in the breakout room. So I do suggest kind of writing down your questions and hanging on to your thoughts about projects that you would like to follow up on. So with that, I am going to hand it over to our first student presenter in just one moment when I share my screen. All right, we are ready to go.
Hi, everyone. My name is Wei. So this summer, I work with Dr. Jiongxin to explore consistency semantics for distributed systems in serverless environments. Next slide, please. So like nowadays, distributed systems are very common thing. So actually, distributed system is kind of simple. You can just have multiple computers connected together, and you can have a distributed systems. Distributed systems are now used by everyone now because it has some advantages, like it can scale to have more computing power, and it can bring something closer to end users like CDN, and it can also tolerate faults with backups. And I'll show you very classic structure, the primary backup structure. And next slide, please. But it also has some issues. For example, consistency is one of the issue. And so in this example, user A might upload something to servers to the distributed systems. But maybe there's something wrong with the network. So the flow itself can be slow. So another user might not see the image uploaded by user A immediately because maybe the user B is accessing a different server. Next slide, please. And so some consistency semantics have been proposed to address these issues to give some guarantees. Like strong consistency. In strong consistency, maybe the image uploaded by A will be some kind of broadcast to other servers immediately when the image is uploaded. But you can see that the strong consistency can be very expensive. And there are weaker consistency semantics are proposed. And in some situations, they are enough. Like for example, if you are edit an online document, it's enough for you to see your own editings. It's not necessary to other people to see your editing unless you want to share with them. And in real world, there are some real products like Amazon S3 and Amazon SimpleDB. They are using some kind of weaker consistency semantics. Next slide, please. So single consistent semantics is well studied, but the problem appears when we want to combine them together. So this problem becomes more prevalent in the era of serverless computing. So serverless is a kind of new paradigm to cloud computing. cloud computing, it's more friendly to users. It's kind of like you can just upload a function to a cloud and the system will do things for you. So there's no need to consider like the underlying structure. So it's more friendly to developers. But the problem is that in serverless environment, the system might use different components that with different consistent semantics, but the user might unknown of that. So it can bring some issues because if you combine different components with different consistent semantics, the effect of which is not well studied. So the goal for this project is to try to measure or quantify the abnormalities if we want to combine different components with different consistent semantics. And maybe we can use the result to build a better consistency semantics for the distributed systems. Next slide, please. I think I can move on to the next slide. Okay, yeah. So what we basically did in this summer is that we tried to implement in C. Oh, sorry, the previous slide. Can you move can you move one previous slide? Oh, I think there's something wrong with the internet.
I'm so sorry.
So,
my computer was freezing and I couldn't change the slides. My apologies. I'll go back.
Yeah, so this is one of the examples that the network can do something wrong. So sometimes we will have some consistent issues.
I'm trying to get back to your slide that you want. I know which one you want.
So maybe I can and I can talk something about what we did. Yeah, thank you for the summer. So basically we built some like distributed like systems using different structure like the primary backup. So very like classic structure. You have one primary server and you have multiple backup servers, and it can tolerate failures. And we also use single degree paxos and wrap. And these two protocols are very classic consensus protocols that can achieve strong consistency. We try to apply different like weak consistency semantics to the system we have built, like eventual consistency, read my write consistency, and monotonic reads consistency. So eventual consistency means that the reader can get the return from the servers, but the server may return some random things of the previous writes. So read my writes is just like the example of the online document editing. So the reader will get all the writes from the server, and the monotonic reads is kind of a special case of eventual consistency. It guarantees that the information returned from the server is the version is increasing with time. Next slide, please. So with the system we built, we also designed some experiments to measure the abnormalities. For example, in this primary backup structure, one of the experiments is that the client might write something to the primary, and the primary server will sync to backup servers according to its consistent semantics. And then at the same time, the client will read the information from the backups. The clients might have some expectations for the information returned from the backup according to the consistent semantics, and we can compare to measure the abnormalities, and we can also measure the throughputs and latencies. And we got some preliminary data for these experiments. And next slide, please. To sum up, so for this summer, of course, I learned a lot of things about distributed systems, and we also built some different protocols of distributed systems with different consistent semantics, and we design experiments that can allow us to measure or quantify the abnormalities. We have some preliminary data, and our future plan is that we want to continue measuring the abnormalities, and then in new experiments we will try to combine different consistent semantics, and maybe we can use the result to figure out a way that to combine different semantics together, because maybe semantics A has this advantage and not these disadvantages, and semantics B has those. Maybe we can find a way to combine them to get a more efficient and powerful distributed systems. And next slide, please. I want to thank Dr. Jiong for his mentorship during the summer, and I want to thank the Summer Research Group, the Khoury College, to provide this opportunity for us, and a special thank to Caitlin for her support during this whole summer. Thank you so much.
Wonderful,
Yeah,
thank you. Go ahead, Greg.
Yeah, thanks, Kellyanne. So when we listen, thank you. A couple of comments on this. Very confident, very articulate, very clear, right? So I think in terms of the just the professionalism of the presentation, even when the slides didn't advance, you're just very confident and professional, which is great. So congratulations. The second thing is that, and you run into this a lot, particularly with very technical people, is the concept understandable? I mean, what problem are you trying to solve? I thought it was very clear, right, for a short presentation. So really good presentation, very good presentation skills. Here's one thing I think could be better, right, in the future, is that if you describe the problem, and let's say your research efforts really solve that problem really well, right? Suppose it succeeds and the semantic improvements you come through become widespread and adopted by everybody, then so what? Who cares? Why is it a better industry or world, or why does the scientific community advance? Who are you solving the problem for, right? Is this interesting to researchers? Is it interesting to universities? Is it interesting to industry, for instance? On that, do consumers care? So I think if you think about that, this is a really important part, particularly for technical people, is we can spend our time to solve many problems in the world, and it's cool. Very few people can do this, but is the problem worth solving, and does it make a difference in the lives, or the working lives at least, of many people? And that I think maybe you should think about.
Yeah, thank you so much. Yeah, so I think the meaning of this whole project is mainly related to serverless computing, but I think that topic is not a big topic, so I didn't talk too much about it, but yeah, I think your suggestion is very helpful.
Yeah, for instance, with these semantic improvements, you really don't need servers or as many servers. So for industry, right, for cloud computing, this could be an enormous change in their business, how they approach business, et cetera. So there's lots of, I think you already know it, right? But that would be my comment. Very nice though, thank you.
Thank you.
Wonderful job, William. Thank you, Greg. All right, we will move on to our next presentation in just one moment. All right. Next, we have the Microaggressions game project, and I know that our presenters are not using my PowerPoint, so I am going to stop sharing right now.
Sure, thank you, Caitlin. Hi, everyone. This is the Microaggression Games project led by Professor Alexander Toll, and my name is Heng Su. And in this past summer, each of our group members has developed and designed a twine game, transformational twine game. So twine is an open source tool for telling nonlinear and interactive games. And our works are actually an extension to Professor Toll's previous research on interactive fiction that facilitates conversations about the sensitive topic of microaggressions. So what is microaggression? Microaggressions are brave, everyday exchanges that send denigrating messages to certain individuals because of their group membership, such as people of color, women, or LGBTQs. In our work, we incorporate critical race theory, intersectionality, and queer theory, as well as learnings from activists and organizing spaces to study and design transformational games to empower and uplift people of color. And transformational games, as opposed to entertainment games, are designed from the ground up to achieve a particular intended transformation of the players. We use primarily qualitative and design research methods to curate counter narratives and create counter spaces. And next, we'll move to a presentation of our individual works. I'll start from mine. And I developed a game called Golden Age. It is a role-playing twine game about Chinese and Chinese Americans' experiences in the 18th. And it consists of two main sub-branches of stories. One is the California Gold Rush adventure. One is being a nursemaid in a Christian family. And those stories are primarily adapted based on real historical figures' life stories. And the goal of this game is first to present a counter-stereotypical storyline to educate players about the Chinese Americans' integration and contribution to the American community. Second, it's also part of the efforts to overcome the anti-Asian sentiment. And next, I will give the ground to my group mate, Doxa.
Hello, everyone. My name is Doxa, and the name of my game is They Didn't Mean That. And the game is a revamp of Professor Toe's work. In my game, it's about a college student, Sam, who experiences racial microaggression. And in my game, it includes an adaptation of another student, Ashley, who acts as an ally and teaches the player about what a microinvalidation is and why it is very harmful. The goal of the game is to teach microinvalidation, as well as to communicate that it is okay for racial minorities to not necessarily bear the brunt of educating others when they experience a triggering event. So in the game, the player has the option to either talk about the microaggression they experience right there and on there, or wait till a later date where they can then tackle it when they feel at peace, or where they're at a place where they feel comfortable to discuss the trauma that they experience. I hope that after the player plays the game, they can easily identify what a microaggression is and understand that it's okay to choose to rest, and which is a luxury that many racial minorities are not afforded oftentimes. I'm going to go ahead and show a screenshot of what my game looks like, and then I'm going to hand it over to Xing Yu, who's going to talk a little bit more about her game. Thank you.
Hello, everyone. My name is Xinyu Hou. I'm a MSCI student at the Boston campus. The name of my game is What's on Your Mind? It is a transformational game about how to become an ally to someone experiencing microaggressions. So the story takes place at a series of computer science project meetings. Players will learn about different intervention strategies while they play through the game. They will see one of the group members go through different microaggression events and decide whether they will use the intervention strategies to confront microaggressions. Therefore, the central transformation I'm hoping to achieve is knowledge. By the end of the game, players should know that silence communicates tacit approval, and they should know how to apply different intervention strategies. The supporting transformations would be disposition and behavior. After playing the game, I hope that players will feel more confident to intervene and would choose to speak up when seeing other people experiencing microaggressions in real life. And here's a screenshot I took from my game. So right now, the three of us have already finished developing the games. We are currently working on our research study design and the IRB stuff. We're developing pre-test surveys and post-test surveys to capture the differences before and after players play the games. We're also looking for people to play test our games. So if you would like to play test them and provide some feedback, feel free to contact us. We would like to thank Professor Alexandra Toh and Caitlin for this summer research opportunity. These projects would not have been possible without their help and guidance. Thank you.
Wonderful job, team. And if I had any useful feedback as a non-computer scientist to share with you about the games, I would gladly do that. Greg, what are your thoughts?
Well, first, like the first presentation, technical people are often really terrible at telling a story, at storytelling. And both the first two presentations are really excellent about the storytelling. You know, it's visual, it's intuitive, you made a complex topic relatable, right? And this is really cool, right? Most people coming from technical fields struggle with this, but so far, really strong. I like the different inflections of how you're using a same approach to come about with a little bit different result, if you will. That was very cool. And it flowed very well between the three of you. So very impressive. Here is a potential improvement. I think the why of why this is important to do is self-evident. Maybe you could explain that, but I think people should relate to that very easily and quickly. It's not clear, who do you want to adopt this approach? So once again, who does this? Are the three of you going to do it for the world? Is it game companies? Is it social media? Is it the internet broadly? But who are, once again, who are the real customers or target audience of this? Who's going to use it and pick up on this research and put it into the masses? And that, I would say, was completely unclear. It's kind of inferred it would be game companies, but I'm not sure that's the answer on that. So, you know, the product, here's one thing I would urge all of you to think about, and there's no wrong answer nor right answer, is what type of technical professional do you want to be? And there are some people that are very happy to write research papers and file patents and kind of do the cool thing. And this is great, right? You know, American society pays a lot of money, right, for researchers to be able to do that. There is another category of people, and I'll put myself into this, is that once you have the cool idea and can prove it works, I want to see it in action. I want to see people using it. I want to say, hey, that's my product or my idea of the product. And how does that do that? And there is no right or wrong thing, but I think that as young scientific minds, you should kind of decide on that early on, right? Because it will drive a different career for you, and one of the things. So if you aspire for many people to use your research, who are they, right? Who are at least representations of those type of people? But very interesting work in a very human and relatable way. I really think, how do we use the power of the internet, which began as a purely positive thing, and today you could really not make that case, right? It is positive and negative, right? What we see on the internet, how do we turn it back into a positive thing? And I think it can be done.
Awesome.
Thank you.
Thank you, Greg. Yeah, great job, team. Any comments for Greg? Or are y'all good?
Yeah, well, I think we haven't discussed much about on this, and thank you, Greg, for mentioning this. We think it could be used for by educational institutes. That's one of the possible source of customers. But yes, we haven't discussed much on this. That's a good point. Yeah.
And by the way, for all of you, you guys can ask me any question you want. This is meant to be informal and two-way.
Yeah. Awesome. Thank you all so much. I will reshare my screen and we can move on to our next presentation. Oh, hold on one second. It's sharing the Zoom as well. One sec. I don't know why that happened. This is odd. I'm sorry, guys. I'm stuck in a loop. 1 second.
I think it was okay, Caitlin. We saw the slide only. It looked,
Did you?
It looked fine.
Okay, good. Thank you, Greg. All right. I will just pull it up one more time. We'll try it one more time. All right. Here we go. There we go. All right. Apologies, everybody. Okay. Oops. Here we go.
Hi, everyone. My name is Akarandu Ugo, but I usually go by Ugo. I'm a Master's of Computer Science student at Vancouver, Northeastern Vancouver. Over the summer, I worked at Professor Chang in verifying neural network for systems, sorry. And my system was a congestion control policy. Next slide, please. So first of all, what is a neural network? A neural network is a collection of nodes that have numerical weights that are trainable to learn the underlying representation of a data set in order to predict some output. Neural networks have been applied to a number of different fields, such as image recognition, handwriting recognition, and so on and so forth. In these days, neural networks are applied to like safety critical systems, and safety critical systems are quite important because if anything was to go wrong in a safety critical system, it could result in a loss of life or a loss of resources. Next slide, please. So my system was a focus on congestion control protocol. So congestion control protocol is essentially a system that controls the flow of network packets between a sender and a receiver. So it essentially aims to sort of avoid congestion in the network. And our system was drawn from a paper called A Deep Reinforcement Learning Perspective on Internet Congestion Control, whereby they developed or trained this congestion control protocol called Aurora that was able to sort of mitigate the flow of packets between the sender and the receiver. So, but the question is how safe is Aurora? How much can we trust this system in this safety critical situation? Like how guaranteed are we of its success? Next slide, please. So this is where neural network verification comes into play. Neural network verification is the process of verifying neural networks, seeing how safe or unsafe it is. Because with neural networks, you can train them and you can test them and receive a high accuracy, but they're mostly used as black boxes in that we don't really know what goes on inside in most cases. And due to a slight change in the input, you could have a very unexpected output. So neural network verification is a process of essentially looking at all the possible inputs to that network and verifying all the outputs are either if we're getting any safe outputs or if we're getting any unsafe outputs. So in the case of Aurora, we were looking at the features, which was like the sending of the rate of the packets that were being sent, the latency in the network, and we're predicting if the system was increasing the sending rate or reducing the sending rate. Next slide, please. So Aurora performed, I'm sorry, the results section is not filled out here. I think this is not the right slides, but it's fine. It's okay. So Aurora didn't perform. Aurora didn't perform like at 100% optimality. So in some cases, it performed as we expected, in the sense that if the network was congested, Aurora was able to sort of reduce that congestion, or if it was not congested, Aurora was able to increase the sending rate. But in some scenarios where we specified that we're increasing the latency, increasing the rate of packets that we're sending, Aurora was not able to spot that. And Aurora was also doing what we did not expect, which was also increasing the sending rates. So essentially, the results that we got from this study were supposed to create a benchmark for the systems and the verifications community to sort of bridge a gap between the two of them, saying that if you're going to apply neural networks into a system, it's a worthy thing to verify it, and to also show the importance of neural network verification to neural network practitioners. This portion of the research is being contributed to an entire benchmark suite that we're drawing up for next year. And this is just one of the systems that we had in question. Next slide, please. So just recapping on some of my research and some of the things I was not able to go through. This summer, I did quite a lot of engineering with like the neural networks, extracting it from the deep reinforcement learning study, defining some specifications to test for. I faced a lot of challenges in that I had to deal with formats that were outdated. I had to sort of work with different versions of packages like TensorFlow, and going back and forth between the two was very tricky most of the time. But there were a number of solutions that I adopted to achieve my goal. Thank you. Next slide, please. So I'd like to say a big thank you to my professor for introducing me to this field, Professor Cheng Tan, the TA I worked at, Tian Ha Wei, Caitlin Kidder, who is the Associate Director of Network Operations, and my wonderful Director of Computer Science at Vancouver, Bethany Edmonds. Thank you.
Yeah, so Ugo, maybe I can begin. Caitlin can jump in, but once again, very articulate, relatable, easy to understand. My questions are going to be a little bit different on this one, and unfortunately for you, this is an area I've done a lot of work on in the past. So the first thing when you get into is, what problem are you trying to solve? You explained it very clearly, but is there a problem, an existing problem today with this type of congestion in neural nets? Is that a thought, or are there actual, are you responding to people saying, hey, the lack of predictable latency amongst our neural nets is actually creating a problem?
I apologize if I didn't explain it correctly, but the congestion that we're looking at is congestion in like an internet network. So like your home internet and the router type of connection. It's not really like in a neural network. Yeah,
and that's kind of the nature of my question. You did explain it clearly. There has been this is a comment between, is this engineering or more applied research? There has been a ton of work in the industry over the last 20 years on network latency, backup, prioritization of packets. It's inherent in like TCP/IP layers, et cetera. So I would say that particular problem is a real one. It's a very valuable problem to resolve, and I'd congratulate you is that if you continue your studies in this area, you're going to have a lot of job offers, I think. So that's cool, but I'm not quite connecting as to what is the newness of the problem, because I think this problem has been around for at least 20 years.
Right. So the newness of the problem was that to control like congestion in a network, essentially, a different study group created this system called Aurora that controls the study, and they have a neural network that essentially manages the congestion rate. So what we did was verify the neural network that they have in that study to see how safe it is, how verified the neural network they have created to manage the congestion is. That's essentially what that's the newness of our approach.
And the way that the Aurora and that verification would work is you simply have a neural net, you test it against a certain network of networks, if you will, and it either works or it doesn't. Is that what it does?
Yes. We use like representations for the input sets of Aurora and representations for the output sets of Aurora. So if the inputs go through Aurora and fall out of the output sets, essentially, we know that Aurora is violating our specifications.
Got it. All right. So one thing maybe that could come across a little bit stronger is it would appear to me, I mean, suppose it doesn't work. Let me come to that, right? You run Aurora in this scenario, outputs are falling out or you're getting out of bounds type performance of the neural net. Well, then what? I mean, what do you just go back and tell people you need better latency? Because if you think about it, the latency defined by networks or inputs to a neural net are kind of fixed, right? People aren't going to go out and, I mean, if it's local, that's one thing, but latency across Ethernet and broad networks, like, any IP network, unless you're totally in control of a local environment, people aren't going to be able to do anything about it. It's really what's designed into TCP/IP in the network to begin with. So is this more of a quality check for neural networks saying, hey, you're good, you're safe? And if it fails, what do people do?
Yes, it's more of a quality check for neural network. And I do understand the unpredictability that you're talking about, because even the network that we work with here is all in a simulated environment. But yes, we never really addressed, the advanced question you just asked, which is if it fails, what do we do? All we just wanted to see is, if it fails or not, basically.
Yeah, and there's value in that. So, and that's what my encouragement would be in terms of the way you present this network is it's back to a question we've come across is, if it fails, then so what do you do? How does this help people get neural networks to work or work better? And the answer to that will be different, of course, but I think what could come across stronger in this presentation is I think what you're solving for here is to create more of a gold standard for neural network performance, period, right? Does this work and work reliably? Does it not? It's almost, you could imagine, I mean, in the early days of Ethernet, a much smaller university than Northeastern University of New Hampshire became ground zero for Ethernet interoperability testing. I mean, vendors from all over the world beat a path to UNH so that they could actually get the seal of good housekeeping approval from UNH that in fact their Ethernet switches, routers, NIC cards, whatever, were interoperable, right, to the rapidly evolving global standard at that point in time. Maybe one way to cast that is that's what you want Aurora to be, is the good, the seal of approval for neural network performance. And if that's roughly right, that could come out a little stronger, I think, in the presentation would be my comment.
Thank you.
Okay.
Thank you both. Excellent presentation. All right, I'm just getting back to our presentation and then we will move on to our next research group. Here we go.
Hello, everyone. So in this past summer, we worked on predicting cyber sickness ratings in stereoscopic videos using 2D convolution neural networks under Professor Gilgit. Please. So before getting into the project, I would first like to talk about cyber sickness a bit. So as we all know, cyber sickness refers to unpleasant side effects such as nausea and dizziness, which has been invoked as a result of exposure to certain virtual reality experiences. It has been proven to be a real problem for people when they put on a headset and enter into the world of virtual reality, especially with the advent of 360-degree cameras and head-mounted displays. Therefore, it has become important for us to address this problem of cyber sickness, which has been induced due to these videos. So in this project, we have introduced a deep learning model to predict the degree of motion sickness induced by these videos. So we have employed two features of the VR content, which is Saliency and Optical Flow, which I'll talk about in the coming slides. Next slide, please. So at the beginning of the project, we aimed at answering these research questions, like the first one being, can we actually predict the cyber sickness ratings from these 360-degree videos, whether optical flow and saliency actually affects the degree of cyber sickness induced, and whether 2D CNN model is good enough method for predicting these ratings. Next slide, please. So for the data set, we chose a data set which consists of 19 videos, each of 60 seconds long. And from these videos, we have extracted optical flow and saliency maps. So to start with optical flow, it captures the velocity in a VR content video. So there are two types of optical flow maps. One is sparse and one is dense. So in this study, we are more concerned with accuracy. So we have gone ahead with the dense optical flow maps. And we have extracted these optical flow maps with the help of Farniak method. Next slide, please. Moving on to saliency. So saliency map shows the amount of attention that a particular pixel in an image draws from a user. So basically, greater the value of saliency at a particular area, greater the chances are that a human gaze will be fixed at that area. So in this study, we have used a static saliency method called spectral saliency. Next slide, please. Okay, so here are three images. The first image is that of a frame from a as is one of the videos in our data set. The second image is that of an optical flow map. So as you can see here, a few of the areas have been accentuated with color. These areas represent the velocity in that particular video. And the final one is the saliency map. So the objects which draws more attention from a user have been highlighted over here. Now Kavya is going to talk about the model and the results. Next slide, please.
Hi. So as Duty mentioned, for utilizing those feature maps, we extracted 120 frames from each of those 60-second videos and generated the optical flow maps and saliency maps for each of those frames. After generating those features, we passed them through a complex CNN model, which had approximately 6 to 7 convolutional layers, followed by a fully connected dense network with 6 hidden layers, which at the end was utilized to predict the cyber sickness rating. Here, out of those 19 videos, 15 videos were used for training purpose, while the 4 videos were used for testing purpose. And since it was a prediction model, we have utilized a linear activation function for the output node and used the mean square error as a loss function to measure the performance of the model. Next slide, please. Using this similar type of CNN models, we tested the model with different combination of feature maps, that is optical flow with and without data augmentation, saliency with and without data augmentation. Since we have less amount of data points, that is a less amount of videos, we have employed a data augmentation technique of pixel shifting to improve the performance of these models. After conducting this entire experiment, we concluded that the most optimal model is the one with optical flow with data augmentation, which has the average RMSE of 14.432, as we can see in the graph from the next slide. Yeah. So as we can see, the optical flow with data augmentation has the least amount of RMSE value, whereas the saliency, whereas the models in which we utilize the saliency maps are having a little bit more RMSE value. So next slide, please.
I'm sorry, what is the vertical axis mean, BMSE? What does that mean, please?
It's RMSE. That is
oh,
the
I see, I read it wrong.
Error.
All right, got it.
Yeah, so now as a result, when we looked at the predicted values for the test set videos for the most optimal model, we observed that the RMSE values are still high, mainly because of the 2 videos, that is the dots outer and the helicopter crash. Next slide, please. When we looked back into the original data set, we discovered that there are 2 different videos, that is the dots all and dots inner, which are similar to dots outer, with substantially lesser rating of cyber sickness, which in turn gave us the erroneous values for dots outer. Like while looking at this video, we realized that our model is failing with respect to understand the depth perception of these dot points. And whereas for the helicopter crash, as we can see in the next video, it was one of the static videos, one of those 2 static videos that was present in our original data set, whose cyber sickness ratings are pretty low, which indicates that our model fails to distinguish between the static and non-static videos. Now, looking into all these failures of these 2 particular videos, we realize that we might need to include more of static videos, as well as we might need to build up a map which can interpret the depth perceptions. So next slide, please. Hence, we can say that the poor model performance can be attributed to the smaller number of data points used to train this network. And as a part of future work, we plan to collect more data ourselves and experiment more on the same, which might improve the performance of the CNN models utilized to predict the cyber sickness rating accurately. Next slide. Lastly, we would like to thank Professor Yildirim, the summer research program, and especially Caitlin for helping us throughout this entire summer and providing us with this wonderful opportunity. Thank you.
Well, fascinating project. And let me make 2 comments and 1 question on this. And the comment is, the whole intersection of computer science and the human mind is fascinating. And it comes out with different results than you think. And I'll give you a couple examples of things you use every day. The voice coder, right? Once you're on your smartphone, right? Once your voice is turned into digital information and coded, there is this tremendous industry bake-off, if you will, of what is the best vocoder, and there are many competing things. And interestingly enough, the one that turned out to be the most pleasing to the ear, which is the one you use today, is actually the worst technically. It had actually a lower bit rate than others, et cetera. And I don't think science actually completely understands that. And the same thing for any digital television, et cetera, the MPEG standard for compressed video, same thing. It is not the most mathematically elegant solution that we came up to, but for some reason, human beings like it. So I think that whole intersection, this is a very new type of field with lots of discovery in general, right? And you're doing that. So just interesting field. The second thing I really liked about this is you were pointing out your deficiencies. You're just being very straight on about it. Hey, the model is not good enough yet, right? Here's why. You weren't dancing around it. And I think for all of us, we all want to, be great, and our data is good all the time, and results are always up and to the right. And in real life, this does not happen all the time. And I think you see a real difference in the credibility of professional when you just acknowledge our own faults quickly and accurately and saying, okay, we haven't figured this out, but we're going to, et cetera. And you guys did that. You said, okay, it's not good enough yet. And I really applaud that. Now, I want to come to a different line of questioning on this particular one, but it applies to all the presentations. Is, what is the real target? Is there a measure of goodness that you're striving for, right? What is the victory? When is the victory parade you're going to be, when do you celebrate? And this is tricky, right? So what does success look like, right? Scientifically, if you will, for engineering or research projects. And it's not completely clear. It may not be clear to you yet either, right? And that's okay. But I do think as any part of, think about it, as researchers or potential researchers, one of your target audience is always going to be people that are less technical than yourselves, right? They may be business people, they may be university provosts, right? Who are smart, but may not know anything about your field. It doesn't matter. It may be the government. So the storytelling is important, but everybody so far is doing an excellent job of the storytelling, right? It's clear, it's quick, this is super on that. What does victory look like? And then of course, connect what is that victory, that measure of goodness, to why it changes the world, why the impact of getting to that level of goodness is worth the time and the money and the frustration and the difficulty of doing all these complex things. And that I think could be improved.
Yeah, so I think the ultimate goal of this entire project will be to somehow implement it in a real-time world where whenever a user is using this VR content, they get an indication, like based on your selections, the next VR content might be a little bit more of a sickening videos or so that you might be prepared for it. So that is the end goal that we want to achieve. But as of now, we want to improve our model, like considering the RMSE value of 14 on the training data set of like 19 to 20 videos is still very less. And we would like to expand it more to build a better model that can have at least less than 5 RMSE value. Even if it can achieve that, that will be one of the great deals for us.
And that's an example of a super clear answer to the question I just posed. And you can say that, and then you can take, this is the next step. It's not maybe the end step, the next step, and then connect that to why it changes the world.
Thank you.
Right? What is the value to humanity, or is this just a cool mathematical exercise that people that like math enjoy doing? For instance, and I get it on this, but one thing for all of us, this is true whether you're in any engineering or scientific field, there is a common curve in the evolution of a major project. And the curve is like this. One, you have to attract really smart people to do it in the first place, right? So it has to be interesting. Getting people to work together, it's kind of like forming a rock band, right? You need a drummer, you need a guitarist, you need a bass player. They need to play their instrument really well, but actually even more complicated, they need to play music together, which is really hard, right, to make those great teams. But once you have that, there is, then you go get money and approval for it, right? You have to convince other people, right, unless you're privately wealthy and can fund this yourself, that, hey, this is worth a lot of money and time. And this is what I call the excitement part of the curve, right? Everybody is excited and happy. Then it takes longer, it costs more money, it may not work as well as people have imagined. Customers may not adopt it at all, right? Or it takes a lot longer to convince the customer, which is usually overestimated. And then you go into what I call the valley of defeat, right? People are demoralized, the program may be canceled, your sponsors are frustrated and pissed off. Why are you not giving me results quicker and better? And the really great teams find a way through that valley, but it almost always comes, in my experience anyway. It is very rare that things go so well all the time. Suddenly you are, you have the tiger by the tail, so to speak, at every moment. And that's why, as professionals, not only giving the vision, but having incremental points, milestones of goodness, saying, okay, I'm here today, but here's when I'm going to be there tomorrow. You can use this as a mechanism to keep ourselves honest, but also to keep your sponsors honest, saying, hey, you may feel worse today than you did a year ago, but I'm doing what I said I was doing, and you agreed to this, right, at some point. And it's good in both directions. It keeps us honest, and it keeps your sponsors honest too. So I think for all the presentations, this is the people that thrive in this environment are usually pretty good at this sort of thing.
Awesome. Thank you, Greg. In the interest of time, I do want to move on to our next presentation. Great job to our research team.
How are we doing on time? Are we behind?
We're a little behind. So we probably want to keep it pithy if we can. But I'm going to play this next slideshow that is pre-recorded with audio and video. So please let me know if you run into any issues on hearing it, but I will share the audio from the computer, so it should work just fine. So just one moment.
Automatic text simplification uses artificial. My name is Heather Freiling, and I'm here to introduce the Automatic Text Simplification Research Team, led by Professor Raman Chandrasekhar and consisting of myself, Hao Yuhei, and Michael Menzel. Automatic text simplification uses artificial intelligence to transform text into a simpler form. This aids both human and machine understanding. However, when text is simplified, flow and meaning can be lost. Our team has used state-of-the-art transformer technology to develop metrics that directly measure loss of flow and meaning in simplified texts. Existing metrics measure simplification quality based upon structural characteristics and similarity to reference texts. Our metrics do not require references and directly measure preservation of flow and meaning. Here's an example of what I've been talking about. The simplification on this slide left out the words in italics and forgot that this woman hadn't broken a sweat. As a result, the simplification is choppy and doesn't make a lot of sense. We wanted to know if we could quantify these issues in order to avoid them. Bernice is our solution for measuring flow. This slide shows two pairs of sentences. The pair on the left flows poorly. The pair on the right flows well. Our system compares all pairs in the original and simplified documents and gives a measure of how well flow was preserved.
For the meaning preservation metric, it is based on sentence level question answering, and we name it SAM. So we want to solve one question: how to automatically measure if a simplified text preserves the meaning of the original. And our idea is to ask questions to both the text, and it will lead to two answers, answer 1 and answer 2. If the answer 2 is as good as answer 1, then we can define it as a good meaning preservation performance. For the implementation of Bernice, we use a pre-trained BERT-based model to do the next sentence prediction. And based on the prediction results, we formulate our Bernice score so it can represent how coherent a document is. And for the SAM, we use T5-based models to do the generation of questions and also predicting answers to a question. And we use LERG to judge the QA performance. Based on the judgments of LERG, we formulate our SAM score to the range of 1 to 5, so it can represent the meaning preservation performance.
Through our experiments, we were encouraged by our metrics correlation with our intuitive readings of simplifications, as well as some human-scored and annotated datasets. Bernice does show an increased correlation with human ratings when compared to simple averages of BERT NSP scores. This suggests Bernice's incoherent pair term does improve the metric. In the table below, you can see Bernice's scores hews more closely to human rating than the average NSP confidence does. The chart on the right displays Bernice ratings on the one-stop dataset run through two simplification systems. The must simplifier appears to consistently perform at a higher level. We should note, our human ratings are preliminary. They will be expanded using Amazon's Mechanical Turk service. We were encouraged by SAM's correlation with human ratings, as shown in the table to the right. However, the score relied on the generated question being of high quality. Additionally, poor answers were given if the simplification changed the position of the sentence with the corresponding answer. For these reasons, we are reworking SAM to generate multiple questions, as well as to generate answers from every sentence in the simplified text, selecting the highest scored answer for evaluation. As for our next steps, we first want to develop our metrics further. Bernice was tuned mainly on the must simplifier, and we'd like to tune on more systems. Additionally, we want to expand SAM from the sentence to document level. We will also benchmark Bernice on human annotated datasets, as we have with SAM. Finally, we would like to integrate Bernice and SAM to Easy, a collection of text simplification metrics. We encourage you to try out Bernice and SAM in our web app. In it, you can test our metrics on your own complex and simple text or use provided samples. We're working on finalizing the UI and deployment, but you can run it locally using the code found in our GitHub repo.
And I'll just jump in here for a moment and let you know we were able to get a finalized deployment of our app up and running. So Caitlin, could I share screen, please?
Yes, you should have permission to do so, but if you don't, I will make sure that you do.
All right. Okay, can you see?
Yep, looks great.
All right, so this is our app. And as you can see, we have a very detailed explanation up here. I think the important thing to know is that a Bernice score of 100 means that we had equivalent cohesion between the original and simplified text. And a LERC score of 4.5 is the midpoint for now while we're still tuning the metric. If you'd like to play with this, I can put the URL in the chat. You can choose between provided samples and just putting your own text in. And for the SAM metric with simulated reading comprehension, you can use pre-generated questions, or if you set this to true, you can input your own question and answer. So if I just scroll down here, you can see we have an article about Scott Kelly. We have two simplifications, and depending upon which simplification you would like to look at, you can come down here, click evaluate, and you get scores, as well as this concept of incoherent pairs are really the pairs that our BERT model tells us that is incomprehensible. That may or may not be correct. That's BERT's opinion. On average, BERT is right. So you can see these were the pairs that were BERT rated incoherent in the original document. And then there was just one remaining after the simplification. And that's all.
Awesome. Thanks, Heather and team.
Go ahead, Caitlin. I have a few brief comments, but do you have anything to say?
No, please go ahead.
Okay. Hey, listen, just one thing. When I was in grad school, there were two prominent researchers, Dr. Carol Hafner and Dr. Mitchell Wand, who was the associate dean, and they were experts in this area, natural language processing. And because of their work, and they were my professors, this is a really, really difficult problem, this natural language semantics. So I fully appreciate the complexity of what you guys are tackling. I have one question and one comment. The first thing is it's not clear whether your approach, it obviously works for the English language, which fortunately for most of us, half the world speaks, if not more. Are you targeting other language where the semantic representations will be, of course, different or not? And that was not clear.
Sure, we're currently targeting English only.
Okay, got it. Then the one comment I'd make is that this is clearly well organized and extremely advanced, even at this point. Totally unclear who cares, who is the target audience, right? So who is going to use this at the end of the day? And I have some ideas, but that was completely unclear to me.
Yeah, so our goal is that this become a tool for researchers and product designers, because of course, iteration fuels innovation, and we can't iterate if we don't get feedback on how we're doing. So we want to give feedback in dimensions that currently are not measurable.
Right. And let me offer this. That makes perfect sense, and it may make perfect economic sense too, but it's kind of back to my earlier thing is know thy audience, know thy target audience. So for instance, to do really good research, all of us need money, right? We need funding to go do this. Now, if I were to guess at the total number of researchers in the United States today, and I'm totally making this up, I mean, what would be a guess? Let's say 200,000, something like that, right? I have no idea, but it's not a million, I wouldn't think. Of that research pool, let's say 300,000 to make the number easy, how many of them would have immediate interest in this type of area? I don't know, 5%, right? You're defining an extremely narrow target audience that usually is not rolling in money, by the way. They've got their own funding concerns. And this is neither good nor bad, but I simply want to offer this. This is part of the dance, with research is, are you solving a problem to enough people that you really have a chance of creating momentum? And is it likely that they will come through with enough funding, right? So that you can do what you need to do. Now, I'm not proposing this, but let me give you, just by way of illustration, an alternate idea is online education. Right. For instance, if you look at the online coding courses like Python today, they're using automatic self-grading on the Python code itself. And it's not perfect, neither is this, I'm sure, but you can get a pretty good representation in like a minute on whether your code is robust semantically or not on that. Now, a lot of people in the world are learning English as a second language, and as an auto-grading technique, you could see this could have tremendous appeal, right, to the online education powerhouses of the world, et cetera. Now, there's a lot of money in that, right, that might be interested in moving that along, and I'll just leave that with you as food for thought. It's a very cool, complex project. The end user was not clear to me, and I think as you've got it defined, it's pretty narrow, and you might just want to think about it.
All right, thank you very much, Greg.
Thank you. All right, so we will move on to our next. I can already tell that Greg's going to need to pop into every single research team's breakout room and talk to them more. So next we're going to do a presentation on supportive IDE. So let me get that up and running.
Thank you so much, Caitlin. So hi, everyone. This is a presentation of the research project co-design of a more supportive IDE led by Dr. Abigail Evans and the team members Jiren Liu, Zihan Wang, and Mingming Zheng. So next, please. Thank you. To start with, in short words, our project aims to help no-OS programmers identify misconceptions and improve their understanding of programming fundamentals quickly and independently. We propose a program that will detect errors and find improvement potentials to assist programmers in gaining more helpful experience from regular practices. And sorry, Zihan, I think you are muted.
Sorry. So our research initially intended to answer 3 questions, but we only covered the first and third ones because our IRB application had not been approved to conduct interviews with students, which was important to answer the second question. To learn how IDE can better support fresh programmers, we had to first find out some common errors in students' codes and summarize some misconception patterns through these errors. So to answer the so what and audience question, I think findings from this question are not only essential to this project, but also helpful for future instructors to teach with special emphasis so that students can avoid similar mistakes. While labeling and identifying students' code, we also wanted to figure out some ways to provide more detailed and responsive feedback to IDE users. So now I will invite my teammates Mingming and Jiren to introduce our methods and findings.
So to solve the research problems we discussed before, we conducted several methods to achieve the goal of our project. Then the first approach is to have a qualitative analysis of student work. We collected 60 anonymous complete assignment solutions and carefully analyzed the mistakes or improvement potentials. In order to study students' programming errors more efficiently, we also developed a coding menu. So next, please. Thank you. Based on the concepts delivered by the research paper we have read. And we pull out those errors from student samples and summarize into high-level categories so that we have a more general understanding of the scattered errors. Then next, please, thank you. And then it led to our next approach, implement detection and design exploration of solutions. Each of team member was charged with one specific programming standard error topics such as typecasting, conditional logic, and then the functions. We developed drafts on VS Code extension that will analyze sample codings and generate tips if needed. As you can see in the example, our program will give helpful messages directly above the line. Most of them are not only pointing out errors like the original IDE do, but more importantly, suggesting users to improve their coding expressions. Then it will move on to our findings.
All right, and let's talk about our findings. We've made a student coding manual to classify the mistakes and analyze more than 16 codes in total. There are 5 main classes and 46 subclasses until now. We've shown the 3 most frequent classes here. The first column of the priority showed how severe these mistakes are for our code. And the most frequent class is typecasting when not needed. For example, the casting int and string are not needed in this example. And the second one is overly complicated conditions. In this example, we can combine some logic to make the condition more readable. And students also make many mistakes in the return statement. For example, some students combine the assignment and the return together in the third example. And we do not have enough time to show all the mistakes, so if you are interested, you can contact us to have more information. Next, please. All right. And until now, we do not have any conclusion since the project is still undergoing, but we do have a clear plan for our next steps. Firstly, we will get in touch with more students and talk with them to know the logic behind their mistakes. And this will help us improve our coding manual and strategy to detect mistakes. And secondly, we have a design for our supported IDE. The brief idea included here are our project format. It is a website when facing different mistakes, what is our suggestions, and finally, there's an overall evaluation of the code. That's all for our presentation. Thank you.
Thank you. Well, listen, once again, very articulate, clear explanation of what you're doing and you know, how you're approaching it. And I'm probably starting to repeat myself at this point, but connect that to your target audience and end user. So by virtue of you doing this work and improving the IDE environment, who is the target customer and why do they care?
Yeah, I think our target audience is the novice programmer, and they're kind of the new learning students. They are not fully understand the programming languages, and they still need time to learn. So that's why we think there are potential to improve the IDE that will support those group of people to like giving out tips, suggestions, and helper information to help them while they're doing programming in the IDE.
And that, for instance, is a crystal clear answer, right? That's extremely clear. And I would put that in your presentation, right? You know, this is our target audience, and this is why we're going to make their life better, and this is why we're going to care. You know, this has come up in a couple of presentations, but the whole trend, and COVID really changed the world. Of all the bad things of COVID, this is one good thing, is the whole online learning, remote work thing is changed permanently, right, in the world. I think this is actually, on general, quite positive. And people need to learn new skills without necessarily having the benefit of having a professor in front of you at every moment on that. And this could be a really cool example, you know, of how to do that. But in most of these presentation, you almost want to start with the impact, right? This is our target audience. This is why they will care if we solve this problem. Then you explain the problem and how we're trying to solve it. But very nice work. I get it, and I would bring that forward more strongly.
Thank you.
Great job, team. All right, wonderful. We will move on to our next presentation.
Thank you, Caitlin, for showing our slide. Hi, this is a team of Professor Tamara Pnachi and me, myself, and Maddie on the other screen. So we'll cover privacy-preserving federated learning in adversarial settings. I know it's a mouthful title, but we'll break down. Basically, it's about privacy issue in federated learning. Next slide, please. First of all, what is federated learning? So federated learning is a subset of machine learning. So you may distinguish machine learning by where the learning task is happening. If that's happening as a centralized way, it is a conventional machine learning that you already are familiar with. If the learning task is collaboratively happening throughout different devices, servers, nodes, parties, or entities, then it is called a federated learning. So federated learning is a new way to process distributed data. As a byproduct, it has relatively better privacy solution than a conventional machine learning. And the comic on the right depicts federated learning. There are 5 cell phones, and the triangle in the middle represent a centralized server. So a centralized server wants to create a model based on this 5 distributed data sets. And so this is a shell of the drawing of federated learning. And our concern is about how privacy runs in this case. So next slide, please. So before we move on to the privacy in federated learning, let's go to the big picture. So how about privacy matters in machine learning itself? So people are excited when they hear about machine learning. So they show a smiley face. But when they hear about privacy, they don't usually smile, like they've seen some issues. So it's a known topic that privacy is an elephant in the room. How do you have a better privacy protection, particularly in machine learning? Luckily, we have solutions. So far, there are 3 solutions that we found. One is security multi-party computation, and two is homomorphic inscription, and third is differential privacy. And I'll break down one by one. The first case, secure multi-party computation, is part of cryptography, which uses inscription. Secure multi-party computation allows two or more parties to jointly compute a function over their inputs while keeping those inputs hidden from each other. It is used when zero knowledge is required. Typically, secure multi-party computation protocols builds on tools like Boolean Circuits, secret sharing, or oblivious transfer. Next, the second solution is homomorphic inscription. Homomorphic inscription allows the processing of the underlying clear text data while it still remains in inscriptive form and without giving away the secret key. In other words, it allows the computation over inscript data. Lastly, there is differential privacy. Differential privacy measures the effect on each individual's information on the output of the analysis. When two data sets differ by at most one record, differential privacy checks whether the difference between the outputs from those data sets is less than an epsilon or not. An epsilon is a privacy loss parameter and is a non-negative number. With a smaller value of the epsilon, the data is considered to have stronger privacy but less accuracy. Now let's move on to Maddie's presentation part. Next slide, please. Yeah, thank you.
About federated learning and privacy. So federated learning addresses issues with privacy, in particular ones that come from transmitting personal data by allowing for machine learning models to be trained locally. So in this diagram, the model is local on each of these phones, and the user interacts with the model and provides new data. And that new data updates the local model and is summarized and transmitted to a shared model, which averages all the updates from other users to make a change to the shared model, which is then transmitted back to the local users. And what we focused on this was the way the model chooses which updates to use to make the change, which is called the robust averaging algorithm. And it's important that the averaging algorithm uses only accurate updates to compute changes in the model, otherwise the model won't be correct. So overall, personal data doesn't need to be transmitted or stored, and the robust averaging algorithm updates the model. Next slide, please. Selecting the correct robust averaging algorithm because it's important to choose an algorithm that can recognize malicious users. And one algorithm that we looked at this summer to do that was adaptive federated averaging, which was designed to detect failures and bad updates provided by participants by determining the quality of the update provided by the participant and discarding updates and blocking users that provided low quality updates. And this was determined by how far the user's update was from the aggregated update. However, this algorithm made some assumptions like the number of malicious users, and this algorithm was only successful if the number of users was less than half of the total users. So the algorithm in federated learning needs to be able to adapt to different adversarial settings. So for example, how well would the algorithm handle collusion between malicious users if there were a large number of malicious users, or if the users were giving random data or purposely bad data. And the algorithms that we looked at this summer were privacy preserving in some settings, but not all. Next slide. The overall goal is that there's a robust averaging algorithm that would be able to adapt to changing adversarial environments, such as if the number of malicious users changed, or if malicious users were doing a coordinated attack. And Tamara, Kicho, and I considered a federated learning approach in an adversarial setting where an attacker has a way to compromise a subset of users to execute their malicious intent. And we propose a novel optimization framework to ensure that the learning process stays immune to the considered attacker while optimizing learning cost. And while we were able to get to an experimental stage, Kicho and I learned a lot about federated learning, privacy, and robust averaging algorithms. And we'd like to thank Tamara for her mentorship and support this summer. We're so thankful for her time and her guidance. Thank you.
Okay, just some quick feedback on my end. really interesting problem. So for instance, why is this important? Who might care? The whole world will care about this, right? So it's you're defining a problem that is important to many, many, many people, really good. I personally appreciated the education on what federated learning is and is not, because I didn't know what it was, and I got it right away. So very nice explanation. I think what I would suggest for improvement going forward is simply will come as the project matures, is how do you know, right? What is the target of goodness, right? So you've described the problem, okay, what, measurable outcomes are you solving for? How might you demonstrate this in more specific terms? And you may know that and not be able to share it, or you may just not be at a point in the program to do that. But once again, it is a tricky business, right? With research proposals and funding, you want to describe it pretty broadly so you can kind of pivot and go where you want. And attract a lot of people, but you want to have some measurable outcomes, right? For all the reasons we discussed earlier, and that's not there at all right now. And I assume you'll get to that. But a really fascinating project.
Thank you, Greg.
Good.
Awesome. Great job.
I'm actually glad I graduated when I did, because I would not compete with all of you, that's for sure.
That's very kind of you to say. All right, next presentation. Thanks, team. All right.
So hello, everyone. My name is Gail. I'm a computer science grad student. And this summer, I worked on a project performance debugger under Mike Shaw. Next slide, please. So I'll talk about first our purpose of this project. So interactive debuggers basically are tools that allow users to explore the state of a program. So for those who are into programming and have developed a couple of softwares by now, you all must have used a debugger at some point of time to, maybe figure out what's going wrong in your code, maybe go through your code step by step, figure out what's the bug in your code. So the question arises that why do we need another debugger when we already have so many debuggers in existence? So the problem that we see is that most debuggers have a way to incorporate a way to step through the program. As I said that, you could check what's going wrong with the program, but they do not allow you to check the performance part of your program at runtime. So what do I mean by performance aspect is that most debuggers focus more on functional bugs or something, maybe a security bug, something that you need to fix in order to get to an output. In order to make your program run, most debuggers focus on that. What we are proposing in this solution is to create an interactive performance debugger that not only allows you to debug your security and your functional bugs, we also want you to debug performance bugs. So we want you to debug based on certain performance metrics such as CPU cycles, time elapsed, cache misses, and so on and so forth, just like how a regular debugger would do. Next slide, please. Oh, one slide back. Yep, perfect. So while we were creating this debugger, we wanted to go through certain relevant work which was in this field. Since debuggers and profilers are something that have been in existence for a long time, we wanted to see how other people have gone about this research. What are the things that we basically needed to keep in mind? So these are two examples of well-known debug. So one is TARDIS, that is a debugger, a well-known debugger, which is developed by one of the Microsoft researchers. And the other is gprof, which is an execution profiler, which takes part of the performance part. It can evaluate, the performance of a program by, generating call graphs and so on and so forth. Next slide, please. So as I spoke about debugger, what debugger is, let me just break down into what a debugger should really do. So a debugger is basically a debugging tool that can be used to figure out a bug or to figure out a program, to figure out what's going wrong in another program. If you see the Google definition of the word debug, it says it's a verb, it's an action which is allowing you to identify and remove errors. So as I said before that, we have so many debuggers in existence. We have some examples like GDB, we have DDD, we have Microsoft Visual Studio has its own debugger, whereas other IDEs in different languages all have their own debuggers. Next slide, please. So for our project, what we've done is we've created a debugger from scratch. So we've basically created a debugger which has the functionality for stepping into a code, setting a breakpoint into a code, and maybe allowing the user to see the source code that is being debugged. So when I talk about a debugger, there are basically two parts that I feel come to a debugger. One part is you want to be able to stop a program. That is what we call in technical terms a breakpoint. We say that we want to stop a program at a certain point because we want to analyze and see what's going wrong at that stage. We want to maybe debug line by line. So in order to do that, we're using an int3 instruction. So that's just a signal instruction, which allows the process to kind of halt at that stage. So at the particular address that we want, we're just kind of inserting that and we're saying, okay, when you see that, halt at that stage. And then we kind of do the processing and maybe, let the user decide how he wants to go forward. And along with that, we're using ELF and Dwarf. These are basically two debug information formats. Why do we need that is, so when you're debugging a process is completely in like machine language, right? It's in machine code. But for a user who's using a debugger, he wants to see it in English. Maybe he wants to see his source code. So you need a format to convert your instruction code, your bytecodes to source code. So we use these debug formats that are established to kind of do the conversion between these two. They have sufficient information. So using these things, we've created our working debugger. So if you see the example on the right-hand side, I've just taken functions. Basically, I've just taken a small sample program, which has a set of functions being called one inside the other. So, and if you see on the right side, I've just shown that, when you set a breakpoint at main, when I do press continue, it just shows me the source code as it was on the left side. So it just shows that, it set a breakpoint at a function inside main. So it shows a breakpoint out there, and, you can do, step in and step out. While we did create this debugger, we did face a lot of challenges, and we have a working debugger, which is partially working. We've tested it out on a couple of scenarios, but we still have some work to do to make it a fully functional debugger. Next slide, please. One slide. Yes, perfect. So that was the debugger aspect of our project. The next aspect is the performance part. So as I mentioned at the start, profilers, right? Profilers, when I was talking about related work, we said gprof was a profiler. So what a profiler basically is, it's a tool that is being used by developers, and that can allow a developer to understand performance problems. So, on a external scale, you can just run a profiler, see how your code is performing and how your code is functioning. And when I talk about performance bugs, as I did in our purpose, the performance bug is something that can be defined as a piece of code which does not meet its performance expectation. Now, why performance bugs are important is because if in a real world scenario, as the scalability of programs are increasing, your program might give you the required output, but it might be really slow in doing that. And as the scalability of systems are increasing, this is a challenge that needs to be solved. And this is not something that is just relevant to maybe at an industrial level that, maybe a big company needs to think about performance bugs. It's also good for a developer who's maybe even starting to program. This gives the person a better idea of how they're doing, how they're programming. Maybe they get an idea of, because as a developer, you're not really, at least as a novice developer, you're not really focused on, how fast my code is running. Sometimes you just want, I just want the output. I just want my code to run. But these are certain aspects that, if you maybe start at the ground level, trying to think about these bugs as relevant bugs, this can actually help to create software at a larger scale as well. Next slide, please. So in order to do our implementation of profilers, we wanted to use certain hardware counters. We wanted to use like cache misses and CPU cycles and other possible hardware instruction counters as well. But since I was doing the engineering in a VirtualBox environment, we did face a couple of challenges in order to be able to access these hardware counters from a VirtualBox environment. So for now, we've just stuck with CPU cycle. So using a Unix instruction, I've basically evaluated the CPU cycle of a running function. So if you see the example that I've given the demonstration, So the left side, I've just done different types of code examples. So one is just, you're printing out something. The second is where you're using malloc. Malloc is just an instruction to allocate memory on the heap. Then you have like an empty function which just does nothing, and a file operation. When you look at the code, you would think, okay, there's an empty function. It doesn't require anything. Why should it take CPU cycles? But if you see on the right, it does have certain amount. So all of those things, even, calling that particular function was, it had some amount of CPU cycles. And that's what I believe is something that, people should be more aware of. So if you see the data on the right, we see that, file accessing had, that's a heavy and expensive operation. You can see on the right with the data that, that is an expensive operation. So we've reached to this stage of our profilers where, we've been able to just calculate what the data is based on a function given to it. Next slide, please. So right now we're at the stage where we have two separate modules. We have our debugger and we have our performance counters. What we want to do next is we want to find a way to integrate the two such that based on certain performance measures, we are able to automatically inject or set up breakpoints in a program that's running using the debugger. And we want to also add like an interactive GUI. So right now we just have a command line based GUI, which is not very intuitive to most users. People like to see programs, people like to see visual aspects. So we want to see if we can, include an interactive GUI. And as I said, we had issues with the performance counters, and that's something that we definitely want to include. We'll probably focus more on adding support for these performance counters in the future. Next slide, please. So that's basically about my presentation. I would like to give some special acknowledgements. So my Professor Michael Shah, without whose guidance, I don't think this project is possible. Right from day one, it's been a really good experience, I would say. And Caitlin for, organizing this whole thing throughout the summer. Your help has been really helpful to us. And Jane for providing, your guidance with writing our abstracts, with reading scientific papers. Thank you for giving your time. And thank you.
So very clear presentation. I don't really have any questions. I think you spelled it out very clearly what you're doing and why. It might be interesting to think about what industries would be most interesting in this problem. It's interesting, if you look at compiler symbolic debugger efficiencies, they actually went in reverse these last 10 years. So if you take a language like Python, for instance, it's a very inefficient language compared to C or C++, for instance. So as compute got cheaper and memory got a lot cheaper, people are caring less about how efficient their code is. But I think this will change with this low latency and aspects. If you take 5G networks, for instance, they're really putting a lot of compute power at the edge of the network, and people are going to care a lot about the efficiency of code with things like IoT and things like network edge type processing. So that's a thought for this, but very, very nice. And thank you.
Thank you.
Thank you, Greg, and great job, Gail. All right, so we have a few more presentations. We are running a little behind on time, but I'm okay with that. I hope it's been valuable. We have plenty of time for networking at open-ended at the very end, so no stress there. So next we have a presentation by Brendan Collins. Let me just pull that up and we'll get going.
Hey everyone, I'm Brendan. I've been working on a topic in complexity theory, and so the title of our paper is a quadratic polynomial correlation bounds with mod 3. And I've been working on that with Professor Emmanuel Viola. Thanks, Caitlin. Yeah, we can go to the next slide. So essentially, and I'm going to sort of say a sentence that's not going to make a lot of sense, and we're going to talk about how to make it make sense in a second. Our goal is to show that the correlation between quadratic polynomials modulo 2 and what we're calling the mod 3 function is maximized when the polynomials are symmetric. We can go to the next slide. So the reason we're interested in this question and what this means will become clear shortly. So the general setting for this problem is talking about what's called circuit lower bounds and the P versus NP conjecture. And so Boolean circuits are a simple abstraction of a computer. Technically, they're directed acyclic graphs, but essentially they take a series of binary inputs and they pass those inputs through gates that compute Boolean operations like and, or not operations. And when you combine enough of these together, you can start forming more and more complex operations, like the example below, that computes the exclusive OR operation through a series of nots, ands, and inclusive ORs. We can go to the next slide, please. And so we can classify these circuits by their size, which is the total number of gates in the whole system, but also by the depth, which is the longest possible path from input to output. And these classifications can create families. And as you might ascertain, the more complex that family, the bigger they are, the more complex operations they can, calculate. And so one approach for trying to separate P versus NP, which is essentially a problem of determining which problems can be solved easily by computer versus only verified easily and not solved quickly, is to see if we can create exclusive or explicit lower bounds on which types of circuit families can compute which functions. So for our project, we are looking at, we can go 2 forward, please. There we go. So for our project, we're essentially looking at a polynomial representation of these circuits, and that lets us study them mathematically in an interesting way. And we're trying to look at, going back to that abstract statement, the correlation between a particular simple class of these circuits represented by polynomials and the mod 3 function. And again, what we're trying to show is, if we can say that, as we're hoping to show, that symmetric polynomials, which represent a very specific kind of circuit, have the highest correlation, then we know that this mod 3 function can be computed with a certain level of efficiency. We can go to the next slide, please. We're going to go through a few quick definitions. So intuitively, correlation is taking 2 Boolean functions. So they spit out a 1 or a 0, and we're trying to say, given the same set of inputs, how often do these 2 functions give the same outputs? So looking at the mathematical definition below, if we have 2 functions that are the exact same function, f and g, the probability that f of x equals 1 when g of x equals 1 is 100%. And so the correlation will be 1. They're exactly the same function. Whereas on the other hand, if they agree exactly half the time, they'll be equal half the time and they'll be unequal half the time, and the correlation will be 0. We can go to the next slide, please. And so what we're looking at is the correlation with polynomials mod 2 and that mod 3 function. So polynomials mod 2 are representing a certain class of circuits that's pretty simple. And essentially, we're talking about quadratic polynomials and n variables mod 2. An example of which we have here, x1 x plus x2 plus x1 times x3. And this is just one very specific example of a broad class of polynomials that have these characteristics. All the coefficients are either 1 or 0, and we have at most 2 terms in any individual monomial because it's quadratic. So when we're trying to look at this as a Boolean function, we want to evaluate this polynomial for a given input string. So for example, the string 110 yields the following equation: 1 plus 1 plus 1 times 0, which is equal to 2. And then that's congruent to congruent to 0 modulo 2. And so the Boolean function that's computed by this circuit, represented by this polynomial, gives us 0 for the specific input. A quick extra definition is that a symmetric polynomial is one in which any 2 of those variables, basically those indices, can be swapped around without changing the polynomial. So for example, in the first example, if we switched x1 and x2, the first 2 terms would stay the same, but that multiplicative term at the end would be different. Whereas in this lower example, we could switch any of those x1, x2, or x3 and get the same answer. We can move to the next slide, please. What we're looking at is the correlation with the mod 3 function as sort of a benchmark of a certain type of function. We're looking at the ability to compute. And so the mod 3 function takes an n length input string of 1s and 0s. It adds up all of those 1s and 0s, and it asks, is that sum divisible by 3? If yes, it returns 0. If no, it returns 1. And so we can see for that same example string, that 110 string for length 3, the mod 3 function will return 1, whereas the polynomial evaluation returns 0. So we can see that they're not going to give us the same thing. And what we're trying to look at is across a whole space, and as n grows arbitrarily large, how often do they return the same value, and do symmetric functions maximize the likelihood of returning the same values? We can go to the next slide, please. So now I think the research question makes a little bit more sense with those definitions. The sense that we're trying to solve is, as anger is arbitrarily large, do symmetric polynomials, that specific type of polynomial, correlate with mod 3 better than any other? And if not, can we find and describe the polynomials that correlate better? Next slide, please. So essentially what we did to solve this problem is we found a closed form expression for symmetric correlation. We analyzed some specific other well-defined classes that had nice properties and verified that all of those also, when explicitly calculated, had a lower correlation than symmetric. And then we're hoping to prove via a more general argument that doesn't rely on these specifics that symmetric polynomials exhibit higher correlation than any arbitrary polynomial. Next slide, please. So as I mentioned, I'm not going to summarize this slide. The gist of it is for every explicit class we computed, we found that symmetric was best. And we are in the process of finalizing a proof that shows that any arbitrary polynomial will be worse than symmetric, but that is not quite complete yet. Next slide, please. And so our conclusion is essentially that we need to finish that proof, check it for veracity, and create a formal write-up of that. And next slide is just acknowledgements. I'd like to thank Caitlin for sort of putting all of this together. It's been a ton of work. She's been very helpful, as well as Professor Viola for including me in his group, and Peter and Liam for all their help and collaboration on this project. Thanks.
Yeah, so Brendan, I'll start with a point of humor. My last graduate class at Northeastern for my master's in computer science was called Analysis of Algorithms. You basically did this sort of thing. And I've never been so lost in a class in my life. You know, it was all graduate math students. I didn't know what the hell I was doing 2/3 of the time on this. So I have real respect for those of you that can do this well. A question for you. I get it, what you're doing, what you're solving for. Is this, I know it will work for both, but is this approach more oriented towards seeing if computer code can be NP complete, for instance, and how to optimize that, or is it circuit itself? And you kind of implied circuits. I just wanted to ask that question.
That's a good question. My understanding of it is it's really primarily the circuits, and they're not even truly, like, they're a little bit removed from what actual like silicon circuits are doing when they're actually running computers. But they serve as a sort of useful abstraction to just look at general computability and complexity theory.
Yeah, this may be a little tricky to do, but one thing you might be able to do, I think this is, I get it, and I think it is, the way you described it is more oriented towards this. I would test this against the semiconductor industry. And you know, the big players there would obviously be the processor companies, but FPGA companies like NVIDIA, right, would have an opinion on this matter, on this, and may or may not be attracted to the industry. But that's where, you know, as a point of research, FPGAs are a little bit tricky to program, but you can do it. You could lay down millions of these circuits on an FPGA and test it, you know, against that sort of thing. And that may be one thing worth thinking about too. Could you attract a semiconductor partner to this research?
That's a good point, thanks.
Great job, thank you. Okay, so we have, I think, 4 more presentations, so they should be pretty quick. Thank you everybody for your patience. I want to make sure that we give our student researchers the time and space they deserve to share all of their hard work. So we will move on to one next presentation. There we go.
Hi, everyone. A summer research project is exploring the performance and scalability of cloud-based infrastructure platforms, led by Professor Ann Gorton, and team members are Vijaya, Shireen, Rahul, Akash, Dongli. Next slide, please. So as a software engineer, we constantly make design decisions during custom system construction, and we choose one of the design among the design alternatives which are provided by the cloud provider. So at times, these design decisions are architecturally significant as they can have negative or positive impact on the system's performance, scalability, availability, as well as the cost. So we have chosen, next slide, please. So our approach is, can we use a design of experiment approach in order to investigate how applications behave under different parameter settings? So our experiment allows input factors to be manipulated in order to determine the result. So by manipulating different input factors at the same time, we can identify some important interactions that may be missed when experiment is done with one factor at a time. So next slide, please. So our method is we are taking one parameter, we're selecting a parameter and varying its ranges across in order to determine the result or in order to examine the throughput for the experiment. Next slide, please. So here we have chosen 4 different languages and we have designed a distributed system application based and deployed it on Google App Engine. And then we varied the load across these applications by choosing different parameters. So the parameter that we chose to vary here was number of clients, which across the ranges 128, 256, 512, and then 1024. And the result that we got through this experiment were astonishing. As you can see, the throughput, which is transaction per second for language Go, was the highest, and it is almost 5 times than that of Node. And then throughput in terms for Java and Python was almost similar. So our target audience over here are the software engineers which are deploying applications on cloud and want to get the desired scalability and performance with minimum cost. Next slide, please. So yeah, as we see that throughput for 1024 clients were same for Java and Python in the lower graph. In terms of cost for 1024 clients, Python is leading. And then one of the important results that we found out through this experiment is the price performance graph, which is throughput per instance R. And as it is evident from the right side of the graph, that Go is leading, and then Python, then Java, and then Node. I would like to hand over it to Vijaya.
Yeah, thanks, Shireen. So once we have done the study across various languages, we wanted to choose Go since it was performing really well and fix the number of threads at 512. And then we wanted to experiment with the various parameters available for the Google App Engine to understand how they interact with each other. So if you're not aware about what these parameters are, consider them to be the knobs on a radio. And similar to how the right combination of rotation of these knobs gives beautiful music, the right combination of these parameters gives the best performance. So we chose the target parameters as max pending latency, which is nothing but how long should a request wait before a new instance is spun up to cater to it. Max concurrent requests, which is how many requests can a single server handle in parallel, and the target throughput utilization, which is the percentage of max requests after which a new instance is to be spun up. So once we decided on these 3 parameters, we chose 3 values for each of these, giving us a total of 27 parameters to experiment with. So we wanted to keep the environmental impacts minimal. So we ran the tests over a period of days during the same time to minimize this. So as you can look at the below planes, these planes have been constructed by fixing one parameter as a default value and varying the other 2 parameters. And from all these 3 planes, it is clearly evident that the default is somewhere near the lower end, whereas the optimal, near optimal value is something else entirely. So can we move to the next slide, please? So yeah, once we ran the tests across the 27 selected parameters, it became clear that the default config was standing at 20th position, and there were other combination of parameters which were performing really well. And it can be seen from the table that there is almost 600 requests per second difference between the best performing one and the default configuration. So this had proven to be quite insightful, as the right design decisions would help in reducing the cost as well as enhancing the performance. Once we had these results, we were also curious to see if these data was predictive in nature and if we could predict something from it. So for that, we tried linear interpolation techniques on the 27, the data from the 27 parameters, and then ran the test for those parameters and validated it. So we ran the test for only 4 parameters which weren't present in our test. And in fact, the data which was predicted and the actual values were very close, and the trend was also predicted properly. So this is something we plan on exploring in the future, as we haven't conducted rigorous study in this predictive nature. Next slide, please. Yeah, so we found that the results have been quite promising and insightful to understand the interactions of these various parameters, which would be of great value to architects or the developers who might want to start up on building a new application or deploy their applications on the cloud platform. Also, we have results using the same methodology for Kafka and RabbitMQ. So in case you are interested in knowing more about those results, you could reach out to our team. So what we plan on exploring further is to see if we can use the same approach for predicting the parameters which are not tested already. And also we want to explore how the shared nature of this cloud platform interferes with the results accuracy. So we also plan on writing up the approach we followed and the understanding we have gotten about the interactions, so that it could be presented at a workshop, and then it could be of use to the industrial audience. Yep. So special thanks to Professor Ian Gorton for his constant support, and Kathleen for facilitating this summer research program. Thank you.
You know, I credit all of you for hanging in there. We're getting on with a couple hours here, but very impressive. And you know, it's just very impressive, right, at the intellectual firepower, right, that you all represent. So just a quick comment on this one. What you're doing and how you're doing it is clear. I love the use of data in an intuitive way. You did that very well. I'll come back to who's the target audience in this. And this strikes me is that the target audience is yourselves. In other words, this is very interesting to publish against, right? And this is a cool thing to be able to do. But linking that to an industry problem or a society problem, you know, much less clear. So my takeaway, if this is what you intended, very cool research work. I think there will be an interesting paper about this at some point in the future. Linkage to something else was not clear.
Okay, so the intended target audience are the developers and the architects across the tech industry. So as the days are progressing, more and more companies are migrating towards cloud environments. So when they are making the design decisions at an initial phase, this kind of work would provide them with a benchmark of how the test could be conducted for their specific use cases. And also they could get an understanding about how to tweak the parameters based on the inferences we provide.
Got it, right. So a natural set of partnerships or potential customers would be the people that are actually developing compilers and code environments for these different languages and approaches, correct?
Yeah, and also the developers who are building various applications and deploying them.
Okay, super, thank you.
Wonderful, thanks team. All right, on to our next presentation. Thank you everybody for hanging in there. Now it's a lot, but hey, we're doing this academic conference style, right? All right.
Could you hear me?
Yes.
Okay. Hello everyone. My name is Jin Yanpan, and I'm following Professor Gomez to do this summer research. My topic of this summer research project is list curation. Next page, please. People often use the internet to search for a variety of materials to find the resources they need in daily life. For example, they look for a resource on Kelly Blue Book for used cars, and on Amazon to find or even buy items they want. However, this website only offers the most viewed or most purchased items. Sometimes these items aren't what users like. Next page, please. So here we got the research question. Users may want to browse some data that they are really interested in to help them to make decisions rather than doing through someone else's performances. We want to design a toolkit that would help users find the data they were interested in. Next page, please. For this goal, I found some related works. I will introduce two of them which are interested in me. First one is IMA search. The author proposed IMA ranking to approve human predictability of other attributes by weighting the monotonicity of the primary ranking attributes to rank multiply attributes similarity. Next page, please. So the second one is lineup. Lineup use bar graphs and solve complex ranking text through interactive technologies. These solutions gradually sorted by the attributes or attributes that the user decide to use, but this would neglect the need for other factors. So it wasn't really what we want. In our version, the way to discover data of interest to users is to infer and find data in the database that might be the interest to user by looking at their browsing and notes. Next page, please. So we want the toolkit to be composed of 8 modules: data aligner, sorter, filter, summarizer, annotator, signer, detailer, and recommender. In this summer, I finished the data aligner to upload the data set, the sorter to rank attributes, the summarizer to summarize the data, and the signer to record the data which has been seen. In the future, we will improve the filter to help user to filter information, and annotator to take notes, detailer to overview data, and recommender to recommend data for users. Next page. Thank you for listening.
Okay, thank you very much. You know, complicated and interesting work. What is the approximate timeline of the research? So for instance, if you take a look at where you are today, what would be a midpoint of the project, or what would be an endpoint in time, for instance? Yeah, Chimwan, you're muted. You're muted.
Maybe end of September.
Oh, that's fast. Okay, okay, very fast. Okay, thank you. Congratulations.
Awesome. I know I would love to use a sorter like that, so I'm excited to see where the project goes when I'm looking for things to buy on the internet. Okay, so next we have 2 more presentations. This one is on object detection in airplane inspection, and our researchers are going to share their own screen. Here we go.
Good afternoon. My name is Minna Reyes, and my co-investigator is Ruchi Bhavsar. We're both computer science master students at the Boston campus, and we'd like to start by saying thank you to Nicole and Eric, our principal investigators, as well as Caitlin and Jane for all your support during the summer and this whole experience being your brainchild. Thank you for that. And also thank you to Greg for joining us today. Thank you everyone else for staying through to the end and for your kind attention. And to start, we'd like to ask you to consider, what is it that makes a plane airworthy? Is it the age or the engineering prowess or how comfortable the seats are? For our team, it's the screws, dents, cracks, missing paint, in short, the nuts and bolts, if you'll pardon the pun, that matter most. Our question then was this: can we use machine learning and specifically object detection tools to detect these flaws with high precision and make flights even safer? Currently, small craft require routine overnight inspection at minimum once per month. This inspection takes roughly 2 hours. Now, using unmanned aerial vehicles, or in common parlance, drones, to capture aircraft images encompassing the same inspection requires only 15 minutes. Thus, in a fleet like Air Canada's, which has 384 aircraft, that amounts to a savings of 3,916 inspection hours per annum. Since the feasibility of capture has been shown, we turned to the other side of the coin this summer, namely how to accurately diagnose flaws from said footage. Now, aircraft maintenance engineers have an error rate of up to 30%. Our second structuring question was, could we use machine learning to improve on that error rate? Our motivating considerations were a combination of improving safety outcomes, improving inspection efficiency, and directing engineer attention where it's needed most to fixing the aircraft flaws. So this summer, our team, under the lead of Vancouver campus professor Michal Iben, and with additional guidance from British Columbia Institute of Technology professor Eric Sachik, Ruchi, Tan Lam, and I, Minnow Reyes, conducted feasibility research and determined that such object detection was indeed possible, but that it requires adjustments and additional training to meet the expertise level that aircraft maintenance engineers currently have. Over the course of the summer, among other tasks, we collected 244 images of aircraft defects from a Piper Navajo Chieftain aircraft parked inside a hangar. We used Roboflow, a catch-all tool for computer vision datasets, to label our dataset with 6 categories of flaws mentioned earlier in the presentation. Among them were corrosion, rust as one category, dents, cracks, peeling, which we used for generic paint flaws, missing screw, and other. We then used Roboflow again to augment our dataset this time, transforming the images in such a way as to improve the probability that our model will maintain high accuracy in future applications where the conditions under which the images are captured might vary from the conditions under which we captured them, such as lighting changes and plane model. We then achieved this augmentation using Roboflow, data augmentation. And Roboflow helped us flip, crop, and rotate our images at random, among other augmentations. We ended up with a total of 895 images, and my co-investigator Ruchi will share our results.
We used, out of the 800 and some images, we used 712 images, which is 80% of our data set, to train YOLO v4, which is a convolutional neural network that is commonly deployed for real-time object detection tasks to recognize these flaws. The remainder was used as 10% validation and 10% testing. We ran it on Google Colab that provides free GPU, and we trained on Colab as well. The model did detect some flaws after training. Here are some examples on the next slide. That said, after training, it had a low average precision rate across all flaws, topping out at 24% in the best case and averaging quite a little bit lower in most individual flaws, except for missing screws. When it came to missing screws, the model has a 71.59 average precision with 13 true positives and 3 false positives. This was exciting because it is within the error range of a skilled human inspector across all flaws, which suggests that even an early model may be able to match the human accuracy and perhaps surpass it with improved data and additional training. Next slide. Next slide, please. I created a demo to show you the detection at work. I've held up my phone with pictures of a flaw to my laptop camera, and you see the screen capture that the model is able to detect the correct flaw in real time. as you can see, that there's a great promise for not only machine learning driven detection of flaws, but also for that to happen real time and mid-drone flights. To push the project forward conceptually, we'd like to add to the data set, add more images to the data set, and train and test the model again with the additional data set. Our steps beyond that include, steps in the future include writing an academic article about our findings and submitting it to the conferences, multiple ones. Since this is a novel research, we're eager to share our findings and apply them in a real world context where the additional training and adjustment, they can change the face of inspection. Thank you, everyone.
Okay, listen, excellent presentation, super clear. So you defined the target audience, and obviously if this works in aircraft inspection, it can work in a lot of other places too. You defined your approach and you gave enough data to really make it credible on that. If there's any minor thing, and this is really a nit that you might want to throw in, when you're doing this good research and all of you are under very short periods of time, you always want to kind of end with a teaser is here's what we could do if we had more time and energy and money. And it might be as simple as a graph on the YOLO V3 performance and saying, hey, with more data and more time, all right, we're at 74 or 54% accuracy today. We think we could get this to something like 80 or something like that. But really very clear representation, and the demo was very cool. Nice job.
Awesome.
Thank you.
Great job, team.
Thank you.
Thank you, Greg. All right, we're on to our final presentation, and then we'll have a few closing words from Professor Chandra, and we will have our breakout rooms if anybody would like to follow up with any of the student researchers on any questions they have. So I will hand it over.
Hi, so this is from which also I go by Toby. Thanks everyone for staying late. And I will try to go as faster as I could. Anyway, so let's go to the second. Slide. Our project is guided by Professor Michael Rennie-Wolf, and then we actually cooperate with National Research Council at Canada, NRCC, and then our main project is called Read Alongs. It's an existing like machine learning audio text alignment tool, and then this tool is like developed for the indigenous community and to help their like language pass along. Because like nowadays, a lot of those communities, young people are moving out so that their mother tongue is not that familiar by their own people. So in order to solve this problem, NRCC got some funding and then developed out this tool. However, there's some challenge for the user to use it. And then our project, like the goal of our project is we come in and then we try to integrate it, try to make the software easier for people with non-tech background to use. And then, so let's go to the third page. Yeah. So very quickly about how the existing tool works. Right now, the user, in order to do that, they need to understand terminal. And then second, they need to understand like how to spin up a Docker container inside the terminal. And then third, they need to run terminal Python code to perform those tests, namely there are 4 tests: prepare, tokenize, G2P, and then align. So you can see that it's quite challenging for like local school teachers or community members to perform those tasks by themselves. So right now, very often, the users will get the original text file, the audio file, they will send to a researcher in the group or send to a technical person, ask them to do the align and then send the thing back. So the first page. So this is the solution that we provide that in order sorry, I'm repeating myself a little bit, but in order to help the user that's not tech savvy, and also many users in the rural community, they don't have a very good internet accessibility, which is another limitation that we will need to face. And then the third challenge is like many of the local communities, they prefer to keep their own data, like they don't want to share their language data with like big companies or what other service. So that our solution come in, we provided, so we try to understand what's going on, try to understand challenge. We talk with the team about which solution that they will prefer. Initially, we were thinking about, deploying it to AWS so that we can make everything into a microservice. It's more modern. However, due to those main challenge, we decided to to take a different approach and then to make it more like a desktop app. So in the end, we actually rewrap the whole process, and then we extract the code from those terminal lines and then make it into a GUI. Such that the user will be apply the text file, apply the audio file, and then specify which language they're using specifically, all with their like clicking mouse, so that they no longer need to understand Docker, Python, terminal, Linux, anything. So that after that, on the bottom right of the corner, you're gonna see this is the result. They're gonna see an interactive player. They're gonna highlight the language as the audio play along, so that it's easier for them to, learn the language or figure out their pronunciation, those kind of stuff. So I guess last slide. So that being said, with that software available, there's still a lot of things that we feel very passionate and exciting to move forward with. So we actually talked with the team this Monday, the NRCC team, and then we got approval from them to actually make an independent repo and then make it a sub-product to the official reader launch, so that in future release, our desktop app will be able to send out to the community. On top of that, we also have some time so that we will optimize the code and then make it cleaner, maybe refactor the design pattern to make it a little bit easier to maintain, and then some UI improvement. And we also get some feedback from community that there's some extra function they want, so we will be able to add in the future. Cool, thanks.
Cool project, kind of an innovative one. I haven't seen really an approach like this before, so very cool. And a lot of the questions I had been asking, like tie to customers, who cares on that, you're going to find that out once you have that GitHub repository, right? You'll have a very measurable way of saying, hey, is this really interesting to, not so many people, a lot of people, et cetera. So I think you've got a very well-defined control loop on this thing pretty quickly, and very interesting. So nice project. Awesome. And Caitlin, since I know we're over time and I just want to credit everybody with this, let me just quickly say a few closing words on my end and I'll turn it back to you. Hey, listen, in a very genuine way, every single presentation and project is very, encouraging and inspiring to me. I mean, it takes a lot of personal motivation, right, to attempt these sorts of things, and they're hard. And I step away from this actually feeling very positive about the future of this group, and proud that it is coming from Northeastern. So really well done, team. One tool I'll leave you with, and is that when I graduated, I went to work for Texas Instruments for a long time. And at that time, the chief technology officer of TI was a guy by the name of George Heilmeyer, who is long since retired, but he was a famous researcher, a very successful one. And he came up with what is still called the Heilmeyer Catechism. It's Heilmeier, George Heilmeyer. You can look this up easily on the internet. And he used to see many proposals from many research teams. And he would always ask the same 8 questions, and they're excellent. Even now, I've never found anything better than this. So for the future, look up the Heilmeyer Catechism, see if you can answer those 8 questions well. And if you can, you are probably on a very good path. But congratulations, everybody. I really appreciate the time and hard work. And I hope to meet some of you out there one day. So thanks very much. And thank you, Caitlin.
Thank you so much, Greg. Really appreciate all of your time and energy seeing our projects today, and for your feedback. I think you gave some really invaluable feedback to our research team. So thank you so much. So before we jump into our breakout groups, I would like to introduce Professor Raman Chandrasekhar, who is commonly known as Chandra by me and students. And I will share my screen really quick so I can, well, you know what, I'll just read my bio of Chandra. So Dr. Chandrasekhar is a clinical professor of computer science on the Seattle campus for Khoury College. Chandra has a background in research, engineering management, and is specifically focused on addressing real-world problems in AI, specifically in the realm of natural language processing, or NLP, information retrieval, and machine learning. He has worked at a bunch of places in the past, but I will say most importantly, he is now at Northeastern, and he led the Bernice and Sam NLP research team this summer. So Chandra has a few words to share with us about his experience as a faculty member and why he thinks performing research at the master's level is important. Chandra?
Thank you, Caitlin. Thank you for doing this summer research showcase. I thought I was going to take the summer off, and then there came along this showcase, and I was intrigued. And you know, many years ago, almost 40 years ago, Dr. Ramani in the Tata Institute of Fundamental Research in Bombay gave me a chance, mentored me a summer. I went back to him for 2 more summers. We got 3 papers before I finished my master's, and I did my PhD with him. I worked with him for 13 years, and till today, almost 40 years later, I'm still, we are actually editing a manuscript right now. We're working together. He changed my life completely. He got me to fall in love with AI and natural language processing, which is what I've been doing all these years. So that summer changed my life. And I hope for some of you, what you did this summer is something that changes your life, even if it's in a small way. I think of this as one more way to pay back what Dr. Ramani did for me. And this has just been a labor of love. I had great fun working with Heather, Howie, and Michael in my group. They read, I actually threw a lot of work at them. They read a book, they read a ton of papers, and they read even more papers. They looked at a lot of problems, zoomed in on a problem to solve, found code and related papers, read even more, did some research, found some issues, tried to work around them, found out some other things to do, and created an app to demo the whole thing. The whole thing is, I like the fact that Greg keeps asking everyone, what use is it? Who's going to use it? And this is something that, like in my bio, I say I look for real world applications. But for me, learning is also an end to itself. I started my work in text simplification, and I actually wrote the first paper on text simplification, but that came out of work that I did with understanding how children learn language. So, if Greg had come and asked me, why do you look at how children learn language? It is because I want to know how they learn language. It is no other reason. But then it led to practical applications. So for me, what these people did this summer was great. I looked at all the things that every team had done. Look at the range: consistency semantics, federated learning, microaggression and games, cyber sickness prediction, better IDs, better debuggers, verifying neural nets, text simplification metrics. The polynomial mods was something that I'm particularly happy with because it's something that's way out of left field for me. And like, Greg was saying, it's something that Brendan was able to explain very clearly. I love that. Work on scalability, list curation, the endangered languages work, the object detection work, the fascinating range, a great amount of work. I hope, many of you found your passions this summer. I hope the summer helped you decide what you want to do in the future, what direction you want to go, whether you want to do a PhD or not. I hope this summer helped you. I hope you continue working what you're doing. And again, I want to emphasize, learning to me is an end in itself. It is fun. It is something that I hope you had fun doing. And I hope you had a really productive summer. And I hope you get to enjoy the rest of the summer there. I do want to again thank Khoury for creating this opportunity for everyone, for making my summer fun, for making hopefully a lot of people's summer fun. And thank you, Caitlin. I cannot thank you enough I know how much work you put into it. And, I always remember the Charlie Brown cartoon, which says, thank you from the bottom of my socks, because that's deeper than the bottom of my heart. Thank you from the bottom of my socks. Thank you. And Greg, thanks for all the questions and the support you had. You said a lot of the things I wanted to say. I want to, add to that saying, have fun, learn, enjoy yourselves.
Thank you, Chandra. Really appreciate your words and your kindness. It's my pleasure to organize this. So, I, like Chandra, had an opportunity to conduct research when I was a master's student, and it has really set me on a specific trajectory in life, even though I don't work in computer science, I work in education. So thank you so much for that example. And I hope that this has been a great example for students who might not have had the opportunity to conduct research yet in their careers at Khoury College. This might inspire you. So please do feel free to reach out to me if you have any questions, or if I can try to make some connections for you, I'm more than happy to. And thank you so much to all of my students. Your presentations were excellent. I'm really, really proud of you for minimizing and kind of boiling down what you have done this summer to a short 5-minute presentation. I know how challenging that is, so fantastic jobs. So what we have next, so we are obviously 30 minutes over time, so if you cannot stay, that is no problem. But if you would like to ask any of the research team's questions or make comments about their work or kind of have a little chat with them, I do have breakout rooms made. On Zoom, you will be able to join any breakout room that you would like. If you want to switch breakout rooms, you can simply leave the room, return to the main session, and you'll be able to join a different room. Research teams, if you have at least one representative who's able to stay for say 15 minutes or so, let's give that time so that folks can jump around. And I will open those up, but otherwise I'll be here in the main room. Happy to chat with you further, but thank you so much. So I will open those breakout rooms and you should see it right now. Thank you so much, Greg. Really, really appreciate all of your time and energy. I'm going to pause / stop the recording now so we can just chat.
It's a deal.